Hey everyone, if you've ever worked in product development, you absolutely know the inherent friction of turning a gorgeous, static Figma file into perfectly functioning React code, right? It's like this age-old battle, the designer's perfect vision versus the developer's harsh DOM reality. Well, today on The Explainer, we're unpacking a truly fascinating conceptual workflow framework, and this comes straight from Anasup Consulting. We're going to look at an innovative solution that fixes this handoff chasm once and for all, bridging design systems and code with MCP and AI agents.
Okay, let's dive into this and lay out our blueprint for today. First, the design code divide. Second, enter AI agents. Third, the role of MCP. Fourth, bridging the gap. And finally, Anasup Consulting insights.
Section 1. The design code divide.
So to really appreciate the absolute brilliance of this new workflow, we first have to fully understand the massive problem it actually solves. Think about it. On one side, we have design systems. They give us precise color palettes, standardized typography, perfectly aligned components. Basically, they exist in this beautiful universe of vectors and visual perfection. But on the flip side, you have the code base. That's the functional logic engine. Developers are operating in a totally different universe of DOM trees, state management, and responsive breakpoints. Historically, translating between these two completely different islands relies on a notoriously painful human handoff process. I mean, just think about how much engineering time is literally wasted translating a static UI into a functional interface. You end up with endless JIRA tickets fighting over, a 3-pixel padding discrepancy? Or entire sprint cycles just bogged down because a really subtle hover state transition got lost in the shuffle. Vital intent is constantly falling into this massive chasm, causing a huge bottleneck. And this friction, it isn't just annoying. It's a profound inefficiency costing companies countless hours and immense resources.
Moving on to Section 2. Enter AI agents.
So to fix this massive bottleneck, we really need a highly capable entity to navigate the rough waters between design and development. And this brings us to AI agents. Think of them as intelligent, autonomous workers, capable of acting as a dedicated translation layer. They are the active builders ready to cross the divide. Now, it is absolutely crucial to understand how this differs from previous attempts we've seen. In the past, we had these basic code export tools. You probably remember plugins that just generated absolute spaghetti CSS, right? Just bloated, unmaintainable markup that a developer would literally just have to rewrite from scratch anyway. But AI agents are fundamentally different, and it comes down to that word autonomous. They don't just blindly export hard-coded styles, they actively interpret intent. An AI agent can analyze a visual component, understand, oh hey, this functions as a primary call to action card, and then write the semantic, maintainable code that actually aligns with the repository's existing architecture. They're doing the heavy lifting of translation with real reasoning skills, turning that static visual intent into a clean, functional reality.
Section 3. The role of MCP.
Now, what's really interesting about this slide is how it addresses the AI's biggest blind spot. While AI agents are incredibly powerful builders, they have a known weakness. Out of the box, large language models inherently lack context about a company's specific proprietary design tokens or component libraries. You can't just dump a massive, complex enterprise design file into an LLM and expect a cohesive front end. The AI is inevitably going to hallucinate class names or just invent random hex codes. So how do we fix that? Well, this is where the Model Context Protocol, or MCP, comes in and literally changes the entire game. MCP is this vital standard that acts as a secure blueprint, an API layer allowing the AI to deeply understand both the design context and the code structures at the exact same time. So instead of guessing, the AI agent uses MCP to directly query the design system. If the agent needs to build a primary button, it uses MCP to grab the exact padding variables, the specific state changes, and the exact typography constraints defined by the designers. It acts as the ultimate, foolproof translator's dictionary, preventing those hallucinations and giving the AI ultimate contextual awareness.
Let's move to and see how this builds into Section 4, bridging the gap.
Okay, so now that we have our autonomous builders and our standardized blueprints, let's put it all together into a highly practical step-by-step workflow. Imagine a real-world scenario. Let's say a product team is overhauling a critical checkout flow. Step 1. The design system is created and updated. The design team finalizes the new visual rules, the corner radii, and user interfaces in their design tool. Then we hit Step 2, and this is the magic moment. MCP provides the translation context. The second those designs are finalized, the Model Context Protocol reads the updates and feeds structured, deeply contextualized data straight into the AI's context window. And finally, we arrive at Step 3. The AI agent writes the functional code. Because the AI has perfect context provided by MCP, it autonomously drafts the corresponding React component, It imports the correct hooks, maps the exact Tailwind classes, and opens a pull request. Boom, the bridge is completely built. We just moved from a visual design update to a functioning code update seamlessly without a single manual pixel-pushing exercise from a human developer. It's wild.
And this brilliantly illustrates Section 5, Anasup Consulting Insights.
As I mentioned earlier, Anasup Consulting is the YouTube channel behind this incredibly powerful conceptual framework, and the insight they provide here highlights a massive paradigm shift. By outlining this cutting-edge approach for software engineers and product designers, they're showing us how the core economics of product development are fundamentally changing. Think about what happens when you completely remove the translation tax, that massive period of friction between design and engineering. You drastically accelerate time to market. Product teams can iterate practically at the speed of thought. Software engineers and product designers can finally work together in true harmony. No one is bogged down by tedious handoff meetings or minor visual QA testing anymore, because the entire pipeline is seamlessly driven by AI and perfectly standardized by the contextual awareness of MCP.
So, this leaves us with a deeply provocative question to ponder. With AI and MCP successfully bridging this gap, what actually happens to the traditional developer workflow? If autonomous AI agents, guided by this rich MCP context, are handling the direct translation of visual design systems into functional code, the day-to-day role of the software engineer is going to evolve dramatically. It pushes developers away from being manual coders and elevates them to the role of basically editors or AI managers. Instead of writing boilerplate UI markup, developers will spend their time architecting complex back-end logic, reviewing AI-generated pull requests, and focusing on high-level system performance. It really challenges everyone in the tech space, consultants, developers, designers, to rethink their skill sets and their daily future as this tech becomes the new standard. Fascinating stuff to think about. Thanks so much for joining me for this explainer. Keep learning, and I'll see you in the next one.